All right, this is chapter 2, section 7. We are talking about graphs of rational functions. So some guidelines for graphing our rational functions. We're going to let f of x equal p of x over q of x, where p of x and q of x are polynomials. We're going to simplify our function if possible, noting any restrictions on the domain that are not in the simplified function. That would be our holes in the function. We're going to find and plot the y-intercept by evaluating f of 0. We're going to find the zeros of the numerator, if there are any, by setting the numerator equal to 0. And those are the x-intercepts of the entire function. We're going to find and sketch all the vertical asymptotes. We're going to find and sketch any other asymptotes. We're going to plot some more points to get the basic shape and connect everything using smooth curves. There's one more type of asymptote that we did not talk about in the last section, and that is a slant asymptote. If the degree of the numerator is exactly one more than the degree of the denominator, our graph will have a slant asymptote. To find the equation of the slant asymptote, we are going to divide the denominator into the numerator. The quotient is the equation, and the remainder divided by the divisor is the value of the function as x approaches infinity. We're not going to worry too much about that second part, but the quotient is the equation. Okay, there we go. So we're just going to find the asymptotes for this function first. To find our asymptotes, we want to factor the numerator. Gives me x times x minus 1 over x plus 1. Nothing cancels, all right. We have a vertical asymptote at x equals negative 1 then. Now I notice that the degree of the numerator is exactly 1 higher than the degree of the denominator, which tells me there are no horizontal asymptotes, but my slant asymptote would be x squared minus x divided by x plus 1. Sometimes I'll have to use long division on this, but I can use synthetic division. So I'm going to put my negative 1 out front, and I'm going to do 1, negative 1, 0. Bring down my 1, 2. All right, I've got a remainder of 2. This part here is x minus 2. That is the slant asymptote. My slant asymptote is y equals x minus 2. We ignore the remainder. It's just y equals x minus 2. Let's find the asymptotes of this function. Well, the first thing we're going to do is factor it. We get x minus 2 times x plus 1 over x minus 1. You always want to factor it to see if that denominator is going to cancel. This one doesn't, so my vertical asymptote is x equals positive 1. The degree of the numerator is bigger than the degree of the denominator, so there's no horizontal asymptote. But the degree of the numerator is exactly 1 bigger than the degree of the denominator. So that means I can divide to get a slant asymptote. And this one allows me to use synthetic division again. So I'll put a positive 1 there. 1, negative 1, negative 2. Bring down my 1, multiply, add, add. I ignore my final remainder. The 1 and the 0 means that my slant asymptote is just y equals x. All right, now we're going to graph a function. We're going to do just a gentle graphing. We're going to start by factoring everything. So this is 2 over 2x and x, 3 and 1, minus 3 plus 1. Nothing cancels, which means I have vertical asymptotes at 3 over 2 and negative 1. Negative 1. The degree of the numerator is smaller than the degree of the denominator, which means I have a horizontal asymptote at y equals 1, or 0, sorry, y equals 0. I'm going to find some intercepts. If I set the numerator equal to 0, I don't get anything, which means there are no x-intercepts. For my y-intercept, I plug in 0 for x, and I get negative 2/3. All right. Let's plot what we know. I know I have a vertical asymptote at 3/2 and a vertical asymptote at -1. I know I have a horizontal asymptote at 0. Just kind of make that show if I can. And I know that I have a y-intercept at 0, -2/3. That's kind of all we know. And we have to plug in some numbers to find some other points. So let's maybe plug in something over here. F of -2. Plug that in, I get 2/7. So I know it's up here. I know I can't cross this line. And I know that I'm going to get really close to my horizontal asymptote, which means probably going to look like that. Let's try something between -1 and 0. Let's go with -1/2. Plug that into my original function. I get -1. Whoops, -1. Ignore that point. I know that I can't cross my asymptote. I know that I can't cross the x-axis anywhere. So I gotta go up like that. Let's try +1/2, because I gotta figure out what I'm doing over here. If I plug in +1/2, I get -2/3. Which means my graph is going to go back down like this. And let's try something over here so I know whether it's above or below the x-axis. Let's try f of 2. I get 2/3, which means it's going to have to look like this as well because it can't cross the x-axis. And there's my sketch. And one more of these problems. All right, I've got my function. Let's start off by seeing if we can factor the numerator. We can't, which means that my asymptotes, my vertical asymptote is definitely going to be x equals 1/2, because I just set the denominator equal to 0. I don't even have to worry about it. I don't have a horizontal asymptote because the degree of the numerator is bigger. I don't have a slant asymptote because the degree of the numerator is more than 1 bigger than the degree of the denominator. For x-intercepts, I would find a place where this crosses the x-axis. Now I would actually graph that because we don't have a good method. I mean, it could be 1, it could be 1/3, it could be -1, could be -1/3. And for this one, it actually is none of those. My x-intercept is approximately 1.7550. That's coming straight from the graph. My y-intercept, though, I can do in my head. I get 0, 1. All right, those are our only asymptotes. So I start graphing. Put in my dotted line for my vertical asymptote. Sorry, I've got some green that came through from my last page. We're going to plot 0, 1. We're going to plot 1.7550. And now I don't know much else about my graph. So I'm going to try, what is f of -1? I get 5/3. So that's up here. Well, I can't cross the x-axis again. So that means my graph has to kind of come down and then go back up. There's no other way to make this graph work. I could also plug in f of 1/4 maybe, and choose a number in between here, in between the y-axis and the asymptote. That gives me like 1.719, which tells me it's going back up. Let's say if I plug in f of 1, I get -1. It's about there. Well, I can cross the x-axis there. Good. I can never cross it again, though, so let's see what f of 2 is to see whether I cross it or just bounce back under. F of 2 is 1/3, so that means I'm up above the x-axis now. So that means my graph is doing something like that.